Hi students, how are you all today? Today we are going to learn Class 11 Unit 1 Computer Science Fundamentals of Computer. Come, let us see what is in store for us. You will be wondering, what should we learn in this unit? We are going to know about the computers and also the various generations of computer. Do you know, children, we are presently in the 5th generation of computers. So let us know what are the previous generations and how big or small or what components were used in that computers. We will also understand the basic operations of computer. The basic working of computer is input, process and output, or IPO cycle. We'll deal about it in detail in this. We'll also get to know about the components of the computer and its functions, and how to start the computer, or what is the process that runs behind the screen when you press the power button on the CPU. Without any delay, let us go into the session. Children, you would have seen the cabinet opened and you would have seen the motherboard, right? And you will be wondering, every computer has got a motherboard, the basic setup of the computer. What about the father of computer? Yes, computer has got a father, and he is none other than Charles Babbage. Why is he considered as a father of computer? Because of his invention and the concept of analytical engine in 1837. What is it? It is analytical engine, and the year is 1837. What was it? It contained an ALU, or arithmetic and logic unit, a basic flow control and an integrated memory. It had three things. Which are they? ALU, or arithmetic logic unit, a basic flow control and an integrated memory. Integrated means it was built in, which led to the development of the first general purpose computer concept. So Babbage developed a concept for the analytical engine which contained ALU, the basic flow control and integrated memory, and that was the development of the first general purpose computer project. And you know, children, with him he had a friend called Ada Lovelace, and she is considered as a first programmer. She used to write code for Babbage's computer. So you have a father of computer. He is Mr. Charles Babbage, for his development of the concept of analytical engine in the year 1837, which had an ALU, a basic flow control and an integrated memory. And it development of the first general purpose computer concept. Dears, can you imagine any place without computer? Whether it is a shopping mall, whether it is a general store or a pharmacy or a hospital or maybe a gaming center. You name it and you have it, right? There are computers all around us. Every sphere of life, in the field of education, research, travel and tourism, weather forecasting, social networking, as well as e-commerce, right? There are computers wherever you go, and you carry a computer with you, isn't it? You carry a mobile phone, which is a PDA, personal digital assistant, right? Even your classes are going on through your mobile phone or your laptops. Computers have become an indispensable part of our lives. We can't think of a situation where we are without a computer. Computers have revolutionized our lives with their accuracy and speed of performing a job, and it is truly remarkable. It is very difficult to do a weather forecasting or whether to do e-commerce without a computer. Even the space program or all the calculations cannot be done manually. It has to be automated. It has to be done in a manual manner. It is very impossible to do the calculations. So it has to be done using a computer. They use supercomputers to do that. Computers have evolved over years from a simple calculating device to high-speed portable computers. You know that you would have seen the pictures of earlier computers, bulky and heavy, big, huge ones, occupying maybe 2 or 3 rooms of a house. And it is converted into a small, pocket-sizable, small, tiny, teeny thing, which you carry on your go, right? Children, do you know the growth of the industry, computer industry, started with the need for performing fast calculations. The calculations had to be done using computer. That was the first need. Then it has to be done in a faster manner. The manual method of computing was very slow and prone to errors. As we do, isn't it? We try to do the calculation, we make mistakes. So attempts were made to develop fast calculating devices. The journey started from the first known calculating devices called the abacus, which has led us today to an extremely high speed calculating devices. Nowadays also you can find children going for the abacus classes to learn to do the maths very quickly, right? So it started with the invention of abacus. The early men wanted to do calculations. They used stones and pebbles or their fingers, and it was not sufficient. So they started using marking with sticks or things like that. Then they started the invention of abacus by the Chinese or the Japanese. Both of them had their own abacuses. Children, we can classify the computer stages with the development of the technology. Depending on the stages of development, computers can be classified into different generations. We have different generations of computers based on the development of technology. What was the growth of technology at that stage, or what changeover was happened? Based on that, we can split the computers into different generations. Now we will see the first generation computer, the very first generation of computers that was developed during the period 1940 to 1956. And the main component used in that was the vacuum tubes. Check the spelling, children. VACUUM, vacuum tubes. And they had some merits as well as demerits. It was the first computer that was a merit, isn't it? The demerit was it was big in size. It consumed more power and malfunctioned due to overheat. Since it got heated up, it started malfunctioning. It wouldn't function properly. And it used machine language. Input was given in the form of cards, and they had to use machine language to do the processing. The examples for first generation computers are Eniac, EDVAC, UNIVAC. And children, Eniac weighed about 27 tons. Size was 8 feet by 100 feet by 3 feet and consumed about 150 watts of power. So that was our first computer. First computer generation was 1940 to 1956. The component used was vacuum tubes. The advantage or disadvantage was it was big in size and consumed more power, and it malfunctioned due to overheat, and the language used was machine language. You know, children, machine language is the language understood by the computer, isn't it? 0 and 1s, numbers written in binary form. That is called as a machine language. On the picture you can see the first computer, that is our ENIAC. The expansion for ENIAC is electronic, numerical, integrator and calculator. I repeat, electronic, numerical, integrator and calculator. And it was invented by J. Presper Eckert and John Maclay. Presper Eckert and John Maclay at the University of Pennsylvania. You know, children, Pennsylvania University is one of the best universities in the world, and it was construction started in the year 1943 and was completed in 1946. It took 3 years to complete the construction. What is the expansion for ENIAC? Electronic, numerical, integrator and calculator. Who developed it? J. Presper Eckert and John Maclay. Where it was developed? At the University of Pennsylvania. Children, it occupied about 1800 square feet. You know, children, normal houses in our place is around 1200 or 1300 square feet, the whole house. So you can imagine it occupied 1800 square feet and used about 18,000 vacuum tubes. The area was 1800 square feet and it used 18,000 vacuum tubes, weighing almost 50 tons. It weighed 50 tons. Eniac was the first digital computer. It was the first one. Why? Because it was fully functional. It could work completely. The input process output would work perfectly right. So it was considered as a first digital computer. The first digital computer is Eniac, developed by J. Presper Eckert and John Maclay. Now we will learn about the second generation computer or the transistor computer. A second generation computer or a transistor computer is a computer which uses discrete transistors instead of vacuum tubes. And they used magnetic core memory. You know, children, in first generation vacuum tubes were used, but in second generation transistors. So the second generation computers were smaller in size as compared to the first generation computers. This generation, assembly language and high-level programming languages like Fortran, COBOL were used. The systems used batch processing and multi-programming operating system. Batch processing is giving the input as a batch, as a group, and the processor will process it continuously till the work is over. So second generation computers is from 1956 to 1964. The main component used was transistors. They were smaller compared to the first generation and hence they generated less heat and consumed less power. The input type was punched cards and the operating system were used as batch processing and multi-programming. They used machine language as well as assembly language. Second generation computer examples are IBM 1401, IBM 1620 and Univac 1108. Now we will see about the IBM 360 series and Honeywell 6000 series, that is the third generation computers. The third generation computers was from 1964 to 1971, and instead of the transistors of the previous generation, the third generation used integrated circuits or ICs. ICs were the small integrated chips, circuits built into a single chip. The computers become smaller, faster and more reliable, consumed less power, and high-level language were used. Language used was high-level language, which was language maybe like C, C++, high-level language which is closer to the user than to the computer hardware. More English-like usage. The third generation computers used integrated circuits or ICs, and it was from 1964 to 1971. Examples for the third generation computers are IBM 360 series and Honeywell 6000 series. As they were using integrated circuits, the computers became smaller, faster and more reliable, consumed less power, and high-level language were used. Next, we are going to see about the fourth generation computers. We are going to see about the fourth generation. Instead of ICs, they used microprocessors or very large scale integrated circuits. Integrated circuits in the very large scale. The year was from 1971 to 1980. The computers were smaller, faster, and the microcomputers of the series IBM and Apple were developed. Portable computers were introduced. Computers which are bulky, occupying a whole building, it changed to small computers which could be carried around. So that was in fourth generation, and the year was from 1971 to 1980. You can see, children, the fourth generation computers like IBM and Apple were developed. That time the computers become smaller and faster as they were using microprocessors or very large scale integrated circuit, VLSI technology was being used. The computers were portable. It could be carried around at that time. Now let us learn about the present generation, that is till date computer. That is the fifth generation of computers. They used ultra large scale integration or ULSI technology. They are using parallel processing, that is two processors and simultaneously working. Superconductors. Computer size was drastically reduced. Can recognize images and graphics. You can do Google search for your images, right? Introduction of artificial intelligence and expert systems which are experts. For example, there is a medical system, if you give the symptoms, whatever symptoms you are facing, it is able to come to a conclusion about the decision. What experienced doctor can do, that a computer is able to do, and development is going on for that. Able to solve high complex problems including decision making and logical reasoning. Till date we were thinking only humans could reason out and think logically, but they are trying to develop a computer which can mimic, which can do the brain activity of a human being. This fifth generation computers, 1980 till date, and the technology used was ULSI or ultra large scale integration. They are using parallel processing, supercomputers, and computer size has changed drastically. You can recognize images and graphics, and the introduction of artificial intelligence and expert systems. Artificial intelligence, you have your electronic devices in the form of artificial intelligence. Like for example, you can say a washing machine. When you switch on a fully automatic washing machine, it will detect the weight and it will automatically take in the detergent and fill the water and do the wash cycle. That is an example of simple example for artificial intelligence, and it is able to solve highly complex problems, and it can do decision making as well as the logical reasoning it out whether it is right or wrong or what is the correct thing to do. Then you can see the introduction of robots in today's world, isn't it? Next generation of computer, that is the sixth generation computer, that is in future, not very far future, in near future. It is the sixth generation computer. It is going to use parallel as well as distributed computing. You are going to distribute the computing powers to different computers. Computers have become smarter, faster and smaller, and the development of robotics. Natural language processing. Natural language processing is the computer is able to recognize our language and react accordingly. And development of voice recognition software. It is able to identify the voice. The preliminary trends are available here. You can find in your Google voice recognition software, right? You are able to say and it is able to type it out. Children, now we will see the sixth generation computing. The sixth generation computing is defined as an era of intelligent computers based on artificial neural network. Children, an artificial neural network is an attempt to simulate the network of neurons that make up a human brain so that the computer will be able to learn things and make decisions in a human-like manner. Artificial neural networks are created by programming regular computers to behave as though they are interconnected brain cells. It is used to solve the business problems such as sales forecasting, customer research, data validation, and risk management. By using the artificial neural network, we can recognize the hidden patterns and the relations of raw data, cluster, and classify them. Another important feature of the sixth generation computing is the explosive growth of wide area network. Starting from ARPANET, it has grown to a range where you can find cloud computing. The simplest form is storing and accessing data and programs over the internet instead of using your computer's hard drive. Children, everyday life activities such as banking, email, media streaming, e-commerce all use the cloud. An example for cloud computing is Netflix. They are using Amazon Web Services or AWS. The next important thing is natural language processing or NLP. It is a component of artificial intelligence. That means it provides the ability to develop a computer program to understand human language. You know, our language is ambiguous. The way we intone, the way we stress, the meaning changes. So a program should be able to identify all those patterns in our speech and do the processing. That is the meaning of natural language processing. Children, the Indus Valley Civilization or the Harappan civilization forms an important landmark in the prehistory of Indian subcontinent. The civilization offers an excellent example to the modern world in various ways, like their expertise in town planning, water management, harvesting system, as well as drainage mechanism is unparalleled. The optical character recognition, that is the optical grapheme recognition engine for the Indus scripts has been developed by using a deep learning neural network, which is a subfield of artificial intelligence. I told you that artificial neural networks are composed of layers of nodes, and each node is designed to behave similar to a neuron in the brain. The first layer is called the input layer, then you have several hidden layers, and then you have the output layer. Deep learning is a part of this machine learning process based on artificial neural networks with the use of multiple layers in the network. So by using deep learning neural networks, they are able to identify the grapheme of the Indus Valley civilization. Given photographs, scans, or any image feed of an Indus Valley civilization artifact, the system will be able to recognize the inscription, that is a symbol, the grapheme sequence from the image. Children, there are totally 417 symbols or graphemes or characters in the Indus scripts and just 37,000 plus text inscriptions of data just for the machine to learn and attain expert level status. So it is able to identify the script and the grapheme, the representation, the machine is able to identify. You just have to give a scan or just an image of the Indus Valley civilization. It will recognize a symbol or the inscription that is there on that and gives us the output by using a technique of deep learning neural networks. Children, what is a computer? This is a definition you learn from class 1, right? It is an electronic machine or electronic device, and it will process the input according to the instructions given in the form of programs and give the desired output at a very fast rate. So it works on input process output cycle. It may use for storage also. Computers are very versatile. Versatile is the ability to adapt to many different functions or activities, and it does a lot of different tasks such as storing data, weather forecasting, booking airlines, railway or movie tickets, and even playing games. So there are so many things we can do with a computer. So we can say a computer is a versatile machine. And it works very fast. It processes the input according to the program that is given and gives the output we desire, and it will do it in a very fast rate. Children, data is any sequence of one or more symbols. Datum is a single symbol of data. The data requires interpretation to become information. Digital data is preserved in the computer in the form of binary number system as of ones and zeros. They are the basic facts or values. You can have different types of data stored in the computer such as text, numbers, or multimedia. So data is defined as an unprocessed collection of raw facts suitable for communication, interpretation, and processing. So it is an unprocessed collection of raw facts. Some raw facts are there which is not processed, and it is suitable for, the data is suitable for three things. They are communication. You can communicate between the data. You can communicate the data. You can interpret it. You can come to conclusion from it by using the data, and it can be processed. You can do some processing on it. For example, the email I receive is a data, and if I am able to send the email to some other person, it becomes a communication. If I am able to interpret the email, then it becomes a interpretation. I am able to read the information and understand it, then it is interpreted. And it is processed. Depending on the email, I am doing some process, then it becomes processing. So using data, which is unprocessed collection of raw facts, it is suitable for communication, interpretation and processing. For example, the number 134 or 16, Kavita, C, all are data. It will not give you any meaningful information or messages. The data as such will not give you any information, any message which is meaningful, but once you process it, you get a meaningful information from that. Now we will see what is an information. Information is a collection of facts from which conclusions may be drawn. What is information? It is a collection of facts from which conclusions may be drawn. For example, you are given marks in each subject, and once you enter the marks and a program is doing to convert it into total, then the raw facts, which is your marks, individual marks along with your register number, the process is done is the calculation of total. Once it is done, you are going to get the information, that is the total marks you are going to get.